So we're going to talk about relating our standard form and our vertex form. To start off, what form am I in right now?
Vertex.
That's right, we're in vertex form. And what we would like to do is go from vertex to standard form. Okay? Now, to go from vertex to standard, does anyone know what the process is called? That's right. Expand and simplify. So I'm going to call it E dot S, or I'm going to put kind of like a bracket around FOIL, because it's essentially distributive property and then collecting like terms. So what we have here is a bracket that is squared. So to expand and simplify, we need to rewrite this bracket twice. So our next step will say 4 multiplied by x minus 2 times x minus 2 minus 3. So all we did there, because this entire bracket was squared, we rewrote the base twice. From here, I'm going to choose to FOIL the brackets. It doesn't technically matter. I can multiply these in any order because of associative property with multiplication, but we'll FOIL first, okay? And we're going to try to do this quickly since hopefully you're already strong at it. What is x times x? Good. Now, I'm going to teach you to try to do this in your head. What is x times negative 2? Negative 2. And then what's negative 2 times x? So what's negative 2x minus 2x? Okay, so I did that all in one step, that middle term. If you are unable to do that in your head, just write out both and then do the next step on the next line. And then finally, the last one is negative 2 times negative 2, which is positive 4. Great. From here, we use our distributive property again. The 4 needs to be multiplied by everything. And this is going to be really important, what we've done here. I'm going to talk about why after. What's 4 times x squared? That's right. 4x squared. What's 4 times negative 4x? Negative 16x. And 4 times 4 is positive 16. And then minus 3. What is our standard form? Plus 13. Excellent. Okay, good. So we've now gone from where we started. This was our vertex form to our standard form. Now what I'm going to try to do is on the side is do the complete reverse. Hopefully I have enough room. This is called completing the square. So we're going to do the reverse order. I'm going to take this and put it at the top. So we have f at x is equal to 4x squared minus 16x plus 13. What we're going to do here is we're going to change our standard into our vertex form. And there's a couple of ideas we have to talk about. First, we have to talk about what a perfect square trinomial is. We have to talk about common factoring just 2 terms. So this is a process, a very specific process. So hopefully you guys can pay attention for the next 5 minutes very intently. The very first thing we're going to do is divide the first 2 terms, just the first 2 terms, by the coefficient in front of x squared. What is the coefficient in front of x squared?
Excuse me, can Ivan report to guidance, please?
What is the coefficient in front of x squared? 4. So we're going to divide or common factor out the number 4 from those 2 terms. So what that means is this 4 will be in front of the brackets. And what's left in the brackets is whatever those values are when they've been divided. So what is 4x divided by 4? Yeah, so we have x squared. And then what's negative 16x divided by 4? Negative 4. The 13 still stays as the term 13. Now, this term here is important to us. This is our new b term. Okay, and there's a small formula we have to remember. I'm going to write it up here. We're going to take b and divide it by 2 and then square it. This is that b term we're talking about. Okay? So it's going to end up as a very common number, but I want you guys to see what we're creating here. So if I take 4, or you could even take negative 4, it doesn't really matter. If we take negative 4 as the b, that becomes negative 4 divided by 2 squared. What's negative 4 divided by 2? Negative 2. And then what's negative 2 squared? Positive 4. This 4 is very important. It just so happened to be the same term here. That's not always the case. Okay. In fact, I probably should have chosen a different example, but That's fine. The process is the same. We're going to add and subtract that 4 to this bracket. So when we go to write it, it's going to read 4x squared. Okay, actually there's an x here. Minus 4x plus 4 minus 4 plus 13. And let's talk about adding and subtracting 4. What does plus 4 and minus 4 equal when I put them together? 0. So I've added a 0 to this equation. Does that change the equation? No. And that's why we're allowed to do this. We added and subtracted the same number. So it's almost like we're still balanced within this equation. Okay? From here, we take the negative term. So the negative 4, I have to pull it outside of the bracket. And we're going to talk about why we did this in a minute. And when we pull it outside of the bracket, we have to multiply by what's in front. Just so happens this example has a lot of the number 4. So we take negative 4 and multiply by 4 when we pull it out of the bracket. That'll leave us with 4x squared minus 4x plus 4. What is negative 4 times 4 when we pull it out of the bracket? Negative 16 plus 13. Good. This is where I want to draw your attention. This bracket here, it's called the perfect square trinomial. Let's see if I can move it. And it's the exact same as this bracket here. Okay? So what that means is our reversing process, we're essentially here if we were expanding. We're doing the opposite. Notice those brackets are the exact same at this point. X squared minus 4x plus 4. X squared minus 4x plus 4. We're at this point where these brackets are identical. Okay? And the reason we've done this is we're creating a perfect square trinomial. And a perfect square trinomial is a special type of factoring. Okay? So the factoring for this question, we'll go through it. The shortcut for factoring this, and I'll go through the proof after, is the fact is I only have to find the root of the first and last term. So what's the square root of x squared? What's the square root of 4? 2. Those are very important, okay? Because what that's telling us is I can combine this into one factor that's squared of x, which is our first term. 2 is our second term. And this middle term here, the negative, is what comes down. So because it's negative, we bring a negative down. So we get negative 2. We still have negative 16 plus 13 outside of the bracket. Now, I want you guys to notice this. We've now factored this to be x minus 2 squared. That's the exact same thing as up here. And remember, this bracket is squared. A perfect square trinomial has two factors that are identical. Okay? So we'll finish off this question, and then I'll prove that by the way we normally factor. What's negative 16 plus 13? Negative 3. So we have x minus 2 squared minus 3. This is the exact same as our original vertex form up here. What I want to do is this part here, the factoring. I want to prove this, that this is really true, this shortcut I took. X squared minus 4x plus 4. When we factor, okay, we find the factors of the first term. This is 1, so 1 and 1. Factors of the last term are 1 and 4, 2 and 2, and they have to add up to what? Our negative 4, right? So what is it going to be? What's 1 times 1 and 1 times 4? 1 and 4. Will that give it to us? What do we have to multiply by? And they both have to be what? Negative. Okay, so both these two have to be negative. So when I go to put it into its brackets, I get x minus 2 and x minus 2. How can I rewrite that as one bracket? And that is the exact same as this. All we did was take a shortcut. We created this so that this shortcut would work.